So just very quickly then, could you have a go at finding the expectation and the variance for this uniform distribution for me? So what value did we get for e of x? Are we there yet? 21 over 6. Okay. And have you done variance of x yet? We done it? 35 over 12. Cool. Okay. So can you convert these? Okay. At the moment, you notice you've left them as a fraction. Now, to me, a fraction with these two numbers is meaningless. Yeah, it doesn't have any meaning to me. Like, how big is 21 over 6? It doesn't mean anything to me. So always leave expectation or variance, if you can, as a decimal, maybe to 2 decimal places. So 21 over 6, 3.5. And 35 over 12? It's going to be 2 point something, isn't it? 2.9? 2.9. Yeah. Okay. And of course, that would mean then that the standard deviation would be what? What's the standard deviation? It's the square root of 2.9. 1.7? Okay. Okay. So for that particular situation, when we have a uniform distribution such that each outcome has the probability of 1/6, otherwise it's 0, the expectation is 3.5, which means that if we were going to throw this dice lots and lots of times, we would expect to get a value which is around 3.5. Okay? Now, of course, you realise this is completely meaningless because we know in reality, the value we expect to get could be any of them. Yeah, it's each got a fair outcome. Okay? But the variance should be about 3 with a standard deviation of about 2. Okay? So does that make sense what a uniform distribution is? Yeah? A uniform distribution is a situation where every outcome has an equal chance of happening. Otherwise, it's 0. Okay? Now, we're starting to look a little bit more. So hopefully you have this idea of a probability distribution in your head. We've looked at that before. It's simply a way of linking outcomes with their associated probability. Okay? But then we can start to see from characteristics of the experiment that we are doing what type of distribution we expect. And we give them special names. Okay? So as soon as you start to see a characteristic where every outcome has an equal chance of happening, we can call that a uniform distribution. Okay? We'll start to look at, after the applied learning week, situations like Poisson distributions and binomial distributions and normal distributions. Okay? Again, these are all based on characteristics of the experiment that you are doing. So you look at the characteristics of the experiment you are doing, and then you should be able to make predictions about the probability of those outcomes. Does that make sense? Yeah? Good. Are there any questions about what we've done today?